objective, measures of center. Definition number 1, the mean. It's the average. The sum of the data divided by the number of data. We use X with a bar over top of it to denote the mean. Definition number 2, median, is the middle value, or it's the mean of the two middle values. So if we have an even number of data sets, data points, then you're going to take the two numbers that are in the middle, if the data is in numerical order, and then we're going to find the mean, the average of those two pieces. Definition number 3, mode, the piece of data that occurs most frequently. So whatever you see the most often. Definition number 4, an outlier, a data item that is far apart from the rest of the data. So it will be either very low or very high. Vic number 1, outliers affect the mean the most. So the mode is something pretty easy that you're pretty familiar with. Mean and median you should have seen before, but when we talk about outliers, the mean gets affected the most. Calculate the mean, median, and mode. Example number 1. So here's a set of data: 4, 20, 18, 6, 18, 24, 20, 21, 17, and 12. The mode is what you see the most often. So we should see 18 and 18. It shows up twice. And we also have 20 and 20. So 18 and 20 are both modes because they appear twice, more than any of the other points or other data. Mean. So we're going to add all of the data together and then divide by the number of data. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data. So we add them together and divide by 10. You should get 16. So the mean here is 16. The median. Data must be put in numerical order. So all of these numbers have to be arranged either from least to greatest or greatest to least, either one, in numerical order, before you can determine what the median is. So here they are in order from least to greatest, and the easiest way is to just cross off a high and a low every time until we find the one that's in the middle. Well, I have two numbers that are in the middle. So in our definition, either it is the middle number or it is the mean of the two middle numbers. So the 2 in the middle, 18 plus 18, divided by 2. 36 divided by 2, which is 18. So in this case, the two middle numbers, since they're the same, it is the median. How do I know which measure of center to use? So in the first slide, you saw mean, median, mode, and outliers. Outliers are not a measure of center, but they do affect the measure of center. Mode is something pretty easy to determine, but it doesn't really affect what the center is. It's just whatever shows up the most. Mean versus median. To use the mean, use the mean to describe the middle of a data set without outliers. So these don't have extreme values that are high or low. Then we'll use the mean. Advantages, commonly used in business, engineering, and computer science fields. There is only one answer. You can clearly define what the mean is. This is useful when comparing sets of data. Disadvantages, affected by extreme values, outliers. Okay, so an outlier is in the data set, then it's going to affect the mean. The median. We want to use the median to describe the middle of a data set with an outlier. So we would rather use the median than the mean if there are outliers. Advantages. Extreme values, we call those outliers, do not affect the median as strongly as the mean. Useful when comparing sets of data. And there is only one answer. You can clearly say this number is the middle number, the median. Disadvantages. It's just not as popular as the mean. Mean versus median. Examining the shape of the data set. So here you can see a mound shape or a symmetrical graph. This shows normal distribution. You often hear this kind of graph called normal distribution. There are no outliers in this graph, so we would use the mean to describe the center, the measure of center. This graph is called skewed left. There are lower extreme values or outliers over here. So on the left side, that's why it's called skewed left. That's where the outliers are. Skewed right. Higher extreme values, the outliers. So on the right side, that's where these outliers are. So that's why it's called skewed right. In these two, we would use the median to describe the measure of center instead of the mean. Create a dot plot and a histogram for the data. So just looking at the top, a dot plot is a chart consisting of points plotted on a simple scale, a number line, typically using dots, and it shows the frequency. So here we have some information. Student name, Mark, Matthew, Luke, Ruth, Peter, and Mary. Number of people per household. So in Mark's household, there are 2 people. In Matthew's, there are 3. Luke's, there are 3. Ruth, 4. Peter, 6. And Mary has 6 people in her household as well. So we draw a simple number line, and I have all of my data included in this range. So 2, 3, and 6 are all represented on the number line. 2 people in the household. This happens 1 time, Mark. 3 people per household. This happens twice, Matthew and Luke. 4 people in the household happens once for Ruth, and 6 people in the household happens twice for Peter and Mary. So we use a filled-in circle or a dot. You can use X's sometimes, but typically this is the way you will see it. This is called a dot plot. A histogram also measures frequency or displays frequency. It's a special kind of bar graph, you see the bars, that displays the frequency of data that has been organized into equal intervals. So if you look at my scale at the bottom, from 0 to 2, 2 to 4, 4 to 6, 6 to 8, these are equal intervals. 1, 2, 3, 4. These are equal intervals as well. Here I have the frequency and the number of people per household. So I'm displaying the same set of data on a different graph. There are no spaces. Between each bar, there are no spaces because we can account for everything between 0 and 2. Between 2 and 4, between 4 and 6. So if you look between 0 and 2, I have 1. This happens 1 time. 2 only shows up once. It's the only number between 0 and 2. Between 2 and 4, so like 2.1 to 4. Well, this happens 3, 3, and 4. 1, 2, 3 times. So I have a frequency of 3. 4 to 6, so 4.1 to 6. 4.1, not 4, bigger than that. 6 and 6, that happens twice, so I have a frequency of 2 on my graph.